Good afternoon, everyone. Welcome to the spring long range forecast information session. For those of you joining us for the first time, welcome. And for anyone who's joined us for our webinars before, welcome back. It's great to have you. We haven't done a webinar in a little while, so this is very exciting. So before we begin proceedings, I would like to acknowledge and pay respects to the Kulin Nations, who are the traditional custodians of the land and waterways I meet on today, and also like to acknowledge and pay respects to the traditional custodians of all the lands and waterways that we are gathered on in all states and territories across Australia. And I want to pay my respects to their elders, past and present. I also want to extend that acknowledgement to any Aboriginal and Torres Strait Islanders joining us today. We acknowledge and respect their continuing culture and contribution they make to this country. So today we'll be giving you an overview of the long-range forecast. This will include a winter wrap-up, a water briefing, and an in-depth look at spring 2025. So my name is Jordan, and I'll be your moderator today. I'm joined by our talented producers who will be in the background of today's webinar. Together, we will make this webinar as interactive as possible. So before we start off, can I ask for your attention as we cover just a few housekeeping items? So this webinar is being conducted from locations across the country, so please keep that in mind as we may encounter some technical issues during the broadcast. Our broadcast today will run for 60 minutes with plenty of time allocated for questions, and this webinar is also being recorded and the video will be shared with you via email. For first-time webinar attendees, please see some helpful tips on your screen now. Most importantly, note that Q&A icon. I mentioned it just before we started. That's where you can send through any questions or feedback for the presenters during the session, because we want to answer as many as possible during the allocated breaks. We've got people standing ready to go behind the scenes who will be answering some questions via text, but we'll also give these questions to our presenters as well. It's the icon with the speech bubble button that has a question mark in it at the top of your screen. The icon will be underlined and a new window will pop up on the side when it's turned on. If you want to test out the Q&A now, feel free to tell us your name and where you're dialing in from. So thank you to everyone who has sent in questions during the registration process. We've used these to help shape the content you'll see today. Finally, I'm delighted to introduce you to our presenters, Catherine Ganter, Masood Edraki, and Felicity Gamble. So Catherine Ganter is part of the team responsible for the latest weather and climate statistics, as well as issuing long-range forecasts, and she just popped on there. Masood Edraki is a senior hydrologist for the Bureau with experience in water resources management and hydrocarbon projects. And Felicity Gamble currently leads the Bureau's extended prediction team, providing long-range forecasts and insights into upcoming weather and climate patterns for Australia. We really do have the best of the best looking after this Bureau webinar today. It's a packed hour for you as well, including a winter summary, a water briefing, and then the spring long-range forecast. So let's not keep you waiting any longer, and we're going to get straight to Catherine. Don't forget, get your questions in today. We'll get as many answered as possible. So as soon as you think of them, hit that button and start sending them in. All yours, Catherine.
Thanks, Jordan. As mentioned, I'll take you through the recent conditions and set the scene. Okay, firstly, let's take a look at the numbers for the winter maximum temperatures. The map here shows yellowy oranges for the warmer than average days, top 30% of maximum temperature records if you're a numbers person, and the blues show cooler than average winter days, the bottom 30%. There's only the teeniest bit of blue on this winter map, with the rest of the country either above average or in the white normal range. And Australia as a whole was 0.83 of a degree above average. In terms of standout numbers, Tasmania had its 6th warmest winter days in 116 years. The remaining states and territories were well outside the top 10 this time around. Similarly, here's the winter minimum temperatures. Nationally, nights were 0.11 of a degree above average, so relatively close to the median. All states were above average, but the Northern Territory was below average and had its coolest winter nights since 2014. Queensland may have been above average, but the state had its coolest winter nights since 2012. So let's take a look at winter rainfall. As was the case with the temperature maps, the blues here show above average rainfall, so the top 30%, and the pinky reds below average rainfall, the bottom 30%. And I think the thing that really strikes me about this map is how light or average it is this year. Australia was only about 8% below the long-term average as a whole, so sitting somewhere in the middle of the winter numbers. And also, all the states and territories were within 20% of their average, except the Northern Territory, but it's their dry season at the moment, so it's less relevant for them. We often look at the southwestern corner here of WA separately to WA because the weather's quite different. And that region there was actually it was their wettest winter since 1996. So if you're in the southwest, yes, it's been a while since your winter's been this wet. So if we take a look month by month, I'll just draw your eyes to the east coast of Australia. We can see here in June, New South Wales was quite dry. A number of lows affected the east coast during July and particularly in August, several of which came with widespread heavy rain, damaging winds and flooding. I'm based in Melbourne and I was talking to a Sydney colleague during August, and she'd told me that Sydney had reached 350 millimetres for the month. And it turned out Adelaide, Melbourne, and Hobart hadn't yet reached that for the year. So you can sort of see just how different the state capitals have been. If we look in the south of the country, July saw a series of cold fronts bring moderate to heavy falls for much of the south, particularly the very dry parts of the southwest and southeast. South Australia had its wettest July since 1998. August saw further rain for the southwest, while the southeast, including Tasmania, was relatively drier. So, how is the year to date shaping up? Overall, Australia was 2% above average for January to August, but we can see it masks a pattern of wetter weather in the northeast to east and drier for the south and western regions. And Queensland is actually sitting at 10th highest for January to August, while Tasmania is actually driest in 126 years for January to August. So it's been a very dry period for Tassie. In terms of mean temperatures, Australia is 1.19 degrees above average, the fourth highest on record. You can see the bulk of the signal is in the south, with much of southern Australia in that dark orange highest on record colour. The way that the Bureau looks at dryness across the country is by measuring rainfall deficiencies. So specifically, if we look at the pinky colours of the legend, once rainfall is in the bottom 10% of records, we say it's a serious deficiency, and severe is in the bottom 5% of records. So at the moment, we're looking at 3 different time periods: the year to date, a 19-month period, and a 29-month period. And this sort of looks at different patterns at going back in time. And that rainfall that we saw in July and August has eased the year-to-date rainfall deficiencies for some areas, particularly in southwest WA. So we actually don't really have anything left in the southwest. However, the extent and the severity of the longer-term rainfall deficiencies is largely unchanged. So with that in mind, the recent rainfall and pressure patterns have been consistent with the long-term trends that we've seen in recent decades. So this map on the right here looks at April to October rainfall over the 30 years to 2023. And we can see here there has been a trend towards very low rainfall over parts of southern Australia, so those dark yellowy orange colours. And lastly, I just wanted to draw your attention to the sea surface temperatures. And this is just the latest week of data that we have. So the blues here are below the 1991 to 2020 average, and the pinks are above average. And around Australia, we have quite a lot of warmer water to our north and our east. So those pinky colours that you can see all there. And why are we interested? The warmer oceans can provide increased moisture and energy that can enhance the severity of storms and rain systems. And you can also see it's kind of hard not to notice the Northern Hemisphere. Japan has had quite a number of heat records broken during their summer, and just heard they've had their warmest summer on record. Um, and the UK as well, it's a bit harder to spot on the map, has also just had its warmest summer on record. So it's been a very warm period for those in the Northern Hemisphere. So that's it from me for the recent conditions. As Jordan was mentioning, if you have any questions, please pop it in the question and answer box, and we'll have the first round of questions after the next section. So I'll now pass over to Masood to give us the water perspective. So over to you, Masood.
Okay, thanks very much, Catherine, and good afternoon all. So I'll continue with the recent conditions related to water, and hopefully that will be a short presentation. As you know, and as also Catherine showed, winter has been relatively wet along parts of eastern Australia, eastern coast, coastal New South Wales, southeast Queensland, and parts of eastern Victoria. During which this soils got saturated and the overland flow find their ways to the streams and rivers and raised the water level in the rivers to their flat peak heights. So between July and August, we had at least 3 rainfall events that contributed to minor and major river inflow levels across the catchments in coastal New South Wales and parts of eastern Victoria. But I will go through just one of them in the interest of time. Thanks. Next slide, please. All right. So this event is happened during early August when a low pressure system developed over northern coastal New South Wales. And because of the fact that the soil was already saturated, rainfall of 100 millimeter plus for one day and 300 millimeter over the duration of the event was enough to create runoff and raise the water levels in the Hunter and Namoy catchments in coastal Queensland and inland, and coastal New South Wales and inland New South Wales. So this graph shows the Namoy River's flow rates, the daily flow rates in megaliters per day, and the peak flow shows at the end of the graph. That also continued preceding the flood event. And by the way, this is the event during which the temperatures plummeted in northern tablelands and some areas, Tamworth, Gunnedah, Armidale, and other places experienced their first ever snow. And I think in Armidale, they had their lowest daily temperature of 2.5 degrees centigrade during that period. Thanks, Catherine. Next one, please. So this map is comparing the stream flows across winter in June, July, and August. So these are the percentiles of distribution of streamflow in different parts of Australia. As you can see, the southern Australia has remained below and very much below average during the whole winter. Maybe improved a bit in July because of those rainfall events, but even in August. So this is showing basically across the month percentiles. Still remain below average, whereas in comparison in eastern New South Wales, you can see the stream flows were very much above average because of all those coastal events that happen during that period. So the rest of Australia will basically between below average and average and above average. And also there was some improvements in the Western Australia during later parts of the month because of the rainfall events that occurred during that period. Thanks. Next, please. So this is the soil moisture percentiles. So this is the comparison of the soil moisture in the root zone, which is the top meter of the soil, and below 1 meter. This is 1 meter to 6 meter. This is the most recent one. So this is basically yesterday's soil moisture percentiles showing what areas were below average or what areas the dark blue ones are very much or above average or highest on the record. As you can see, the eastern and western parts of the country, and also most recently, Western Tasmania had root zone soil moisture above or very much above average because of all the events that occurred during the past few months. But in comparison, so that was about root zone soil moisture. In comparison, if you have a look at the deeper layer, which is below 1 meter, as you can see, all of Southern Australia, including parts of Western Australia, central Western Australia, have been very much below average or below average. And that has been the case for months, unfortunately, that they have not really recovered during all the rainfall that has occurred in the past few months. And that's particularly important for the deep-rooted plantations, which might want to access soil moisture at depth more than 1 meter. So that would be affecting the plant growth on those areas. Next one, please. Now going to the status of water storages around Australia. So overall, the storages are at around 68% and about 10% less than this time last year. But looking at around the country, as you can see, so the size of the map is showing the status in terms of the size of the circles and also the color. The size shows this capacity of the storages. The color as the blue and green color shows at capacity or above capacity full, and the lighter colors basically lower percentage of water in the storage. As you can see, north it is showing Northern Australia at the moment is around capacity, particularly eastern storages are showing even above capacity. So that means they are either spilling or this is mostly some of them are weirs that are spilling, or they have got flood mitigation facilities that can store more than the capacity during the flood events. But parts of the south, in particular Victoria and parts of Western New South Wales, storages are not doing as well, between like 20, 30, 40% of their capacity is their water status. Next one, please. So this is the comparison of the storage levels at different parts of Australia. So as the Eastern Australia have 80%, 100% in Sydney, 98% in Hobart, in the north 90% in Darwin. In comparison, as you can see, the Adelaide and Perth, although in Adelaide has raised a bit in comparison to the last year, so that means the situation has been almost the same as in last year. The Perth, again, very low, so between 49 to 45% of their capacity. So if you can change it, please. Next one, please. And finally, the the storage levels in the Murray-Darling Basin, which is important irrigation area in Australia, showing in comparison of the northern Australia with the southern Australia, 80% of the level is water level, the storage levels in the north, and 66% in the south. You can see, although in parts of southwest, the storage levels are like showing by green colors are at capacity because of the number of low level storages in the south are much more than north. On the average, Southern Australia is showing lesser water in their storages. I think that I will stop it here, and back to you, Jordan, for the Q&A session. Thank you.
Yeah, thank you so much for starting us off today, Catherine and Masood. Before we hear from Felicity, who's going to give us the outlook, let's get to some of your questions. Now, remember, you hit that little Q&A button at the top of your taskbar and start sending them in. We have our full team on deck to answer the question. And this one, I think I'll throw this to Catherine, actually. This one I feel is so appropriate because Robin has said, it's felt so weirdly warm and sunny this winter. Was that what it was really like, or was it just her? And Greg, on the other side of the coin, has said, I've felt so cold. He's felt the cold so much more this winter. Was it a cold winter, or was it just me? Catherine, sorry, Catherine, this will be a hard question, I think, to answer because it's horses for courses, but let's hear it.
It's a great question. Potentially a bit dependent on where you are. So, for instance, the southeast, we've certainly had some warm, sunny days. And there was a fair bit of Victoria and Tasmania in the top 10% of records. But for the folks feeling cold, there is a couple of reasons why you may have been feeling cold. And managed to prepare this. I've pulled up, this is what 2024 for winter looked like. So this was a very warm winter, both for days and for nights. And so was 2023. This is highest on record that you're seeing there for 2023. So it's been a few years now since most of us have had a winter this cold. And also with the nights being cooler for some areas, it might also be that the mornings have been making them feel particularly cold.
Okay. I honestly thought this was the year that I finally had bad circulation, but I guess maybe not. Felicity, Lachlan has just sent in a question which I thought was really interesting. We've had good winter rain in southwest WA. Can this be attributed to particular climate drivers such as ocean temperatures?
Well, yeah, it's another really good question. And as Catherine pointed out, I think a lot of that area have seen their wettest winter since 1996. So yeah, it certainly has been much wetter than in recent years. It's difficult to say, though, without a proper attribution study or assessment, what is behind that in particular, especially if we're talking about some of those broader climate signals. But certainly there were a lot of very significant cold fronts through southwest Western Australia this year. And I guess the other part of that, and Catherine also pointed to this as well, that and you mentioned in your question about the ocean temperatures, and yeah, warm ocean temperatures can provide that increased source of moisture and energy that can be then rained out when those rain systems and fronts arrive. So there's possibly an influence there too from the ocean temperatures.
Okay, let's stay on sea surface temperature, because you know when someone asks a question, you go, "I've worked here for how many years, and I can't believe I haven't asked this question before." And probably Catherine's the best to answer this. Tessa has said, "How is sea surface temperature measured? Is it with satellites? Is it with buoys? Maybe do you stick our finger in and have a guess? Like, what's the process there?"
Well, yeah, it's a combination. Not necessarily the sticking your finger in, but yes, there's a combination of buoys and ship observations, but we also definitely rely on satellite. So yeah, it's everything.
Okay. Felicity, we'll jump over to you. Madeline has asked, has the weather pattern become more erratic over the past 10 years, or are they just imagining this?
Yeah, that's a good question, and probably something that a lot of people have been questioning from time to time when we have some of these extreme weather events that we've seen over the years. I mean, there is a large variability in our weather systems from month to month or year to year, and climate change is playing a role in that. It means that some areas are in general getting drier. We're seeing more high pressure systems. But climate change is also increasing the intensity of heavy rainfall events to, say, from thunderstorms or just, yeah, you know, some of those coastal lows and things that we see along the New South Wales coast. So warmer air is capable of holding more atmospheric moisture that can then be rained out in those systems. We're also seeing increasingly warmer conditions. So we're seeing quite a lot of heat extremes, probably less, or definitely less cold extremes and cold records broken. We're also seeing higher sea levels, and that means that we're seeing increased impacts along our coasts, and we're seeing marine heat waves, and we're seeing algal blooms. So in that sense, it could be said that, yeah, we're feeling that the weather is becoming more variable or more erratic.
Okay. And I think this might be the last one, sorry, of this first Q&A session, because we really want to get onto the spring forecast. But Masood, Josh has asked, is the soil moisture data modeled or real results from instruments in the field? A lot of people want to know how we do our business. This is interesting. I'm learning a lot.
Yes, so the soil moisture is basically the model from Landscape water model, which has been developed in the Bureau. But in the modeling, we also assimilated with the observed information as well, and has been calibrated against the real and observed data.
Okay, so much like Catherine was saying before, it's kind of we put it all together, and that's how you get your information. Great. All right. Well, like I said, there will be a second Q&A session. That's going to be our major Q&A session coming up after the spring forecast, which we think most people are going to have questions about because it's what's happening in the future. So that's what you're all here to hear. So please put your Q&A questions in, because it does get busy and we want to answer as many as possible, but sometimes we can't get to them. So it's first in, best dressed. So our final, our final Q&A session is coming up, which I just mentioned. But right now, Felicity is going to take us through the spring long-range forecast.
Thanks, Jordan. So Catherine and Masood have given us a really great roundup of what we've seen in recent months in terms of rainfall and temperature and the amount of water in our landscape, streams and storages. And so now it's time to shift our gaze from the past to the future. So we're going to take a look at what our climate model, Access-S, is telling us about what's in store for the coming months as we head into spring. So we're starting here with our spring forecast for rainfall, maximum temperature and minimum temperature. And these maps show the chance of receiving above average spring rainfall or warmer than average daytime and overnight temperatures, averaged for the 3 months, September to November. So this spring, our forecast shows moderate to strong chances of above average rainfall across much of the eastern half of Australia. And you can see that in those green and blue shades in the map on the left. The strongest chances are in inland Queensland and New South Wales, and also parts of northeastern Queensland. There are also strong chances that spring days averaged across the season are expected to be warmer than average across the tropical north of Australia and for much of Victoria and Tasmania. Parts of northern New South Wales and southern Queensland may see cooler than average spring temperatures though. And then for overnights in that map on the right, generally there are strong chances of warmer overnight temperatures across the country, except in that part of southern Western Australia. So those wide areas on the maps, both in the temperature and the rainfall maps, are where we aren't seeing a particular shift in the forecast towards warmer or cooler than average conditions, or warmer or drier than average. The model is seeing a reasonable chance of both outcomes for spring, so we're not seeing a particular signal in those areas. Next slide, please. So we can then break down our 3-monthly rainfall forecast into individual months just to see how that rainfall signal is distributed. And we can see it's pretty consistent across the months through September to November. So September and October, though, are probably looking at being the wetter months, with the rain potentially easing a bit in November. But having said that, model accuracy does decrease the further out the forecast period is. So there is a bit more uncertainty in our November forecast right now, and you may see it change a little bit as we get closer to the start of November. So long range forecasts are based on probabilities. While there are strong chances of a wetter than average spring in the east, it's not guaranteed. There's still a chance it will be drier. It also doesn't mean that it will be raining every day across eastern Australia. There'll be dry periods and there'll be wet days, but overall for spring, the odds are that that the east will see more rainfall than usual for this spring. Next slide, please. So these maps are available on our webpage and they get updated each week on Thursday afternoons. Now, our website doesn't actually have our 3rd month of the season, which is currently for November. It's just a little bonus for this webinar, but you can find months 1 and 2, currently September and October, on the webpage. And if you keep checking back in on our website, you get the latest updates each week. Next week, you'll see September drop away and November will become available. So you're getting a bit of a sneak peek here today. Next slide, please. So another way to get additional insight into the long-range forecast is by looking at other renowned models. And here we have summarised on this slide the top global models, from the European model to the US, the UK, Japan and others. And as you can see, all of the models are showing a pretty consistent forecast for spring. So wet in the east and then a weaker signal in the west. We don't always see this. Often there can be more variation across the models, with some showing drier conditions being more likely and others showing wetter. Or we may see a fairly weak signal throughout. The top left map there with the green duck, it shows the average of all these models together. And you can see that this average map almost perfectly aligns with the Bureau's forecast for spring. So we would say we have additional confidence in this outlook for spring, just due to that consensus across the international models. Now, remember, the Bureau's model and on our long range forecast webpage is optimised for Australia, and it's updated weekly, as I said. So it does contain the most comprehensive assessment for Australia. It has additional maps and things which I'll show in a little while. These other models shown here, they update only once a month, and as you can see, they have a much coarser resolution as well. Next slide, please. A relatively new forecast that we've added to our long range forecast suite are our chance of extreme maps. And these show where the model expects to see unusually warm or cold, or unusually wet or dry conditions. And so here on this slide, I've got the chance of getting an unusually wet spring there on the left, and the chance of unusually warm spring daytime temperatures in the middle and overnight temperatures on the right. So when we say unusually wet, this is compared to normal spring rainfall or spring temperatures for each location. And I'll explain this more in a moment, but For now, just note that there's an increased chance that we'll see unusually wet conditions across much of Eastern Australia and unusually warm temperatures in Northern Australia and in the southeast. Next slide, please, Catherine. Right, so what do we mean when we say unusual? That seems kind of vague, right? So wet conditions in one location, such as say Mildura or Broken Hill, might be considered pretty normal for somewhere in like Bellingen or Byron Bay. So I thought we could break it down a little bit here. When we say unusually wet, we're talking about the top 20% of the climatological range for a location for a particular month or season. And in the case of this webinar, we're talking about spring. So I'm going to use that as our example. Next slide, Catherine. So here we have the spring rainfall observations at Uralla in northern New South Wales for around the last 100 or so years. And you can see it varies quite a bit from year to year. And if you're from that region, you might be able to look at this graph and go, oh yes, I remember that wet spring of 2022, which I've shaded there in green, or that really dry spring in 2019 shaded in brown. If we click to the next slide, and we can rearrange that graph from the lowest spring rainfall to the highest. And look, there we have 2019 right down the end. So that was actually the driest spring on record for Uralla. And 2022 showing up as one of the wettest. Next slide. Thanks, Catherine. So now we divide them into 5 bins. And down the left end with our driest 20 years or so, we have our unusually dry years, the lowest 20% of our historical record here for Uralla. And this means that for spring rainfall, that's below around 130 mils for Uralla. Up the blue end, the highest 20% of our historical record is our unusually wet springs. And for Uralla, this means spring rainfall that's above 260 millimetres. In any year, the chance of spring rainfall falling into any of these bins is around 20%, 1 in 5. But our model can tell us if these odds have shifted at all. So if we go back to our chance of extreme rainfall map, so if we go back a couple of slides, for Uralla, you can see where that dark triangle is, that's where Uralla is, there's an increased chance of seeing an unusually wet spring. So looking at the scale, that green shade refers to around a 40% chance. Now we worked out the typical chance in any year was 20%. So a 40% chance is actually twice the normal likelihood, and that's why we're saying there's an increased chance of unusually wet conditions for this spring in that area. And the same goes for temperature. So for Northern Australia, there's an elevated chance of unusually warm temperatures, 3 to 4 times the normal likelihood. And for the tropical north, this is their warmest time of year. So we know that not only are they likely to see above average temperatures, but they're actually likely to see temperatures in the top 20% of their historical range for spring. And this is their hottest time of year. So certainly something to flag for those that live in the area, particularly those that may work outdoors, run livestock, or work in the health system where heat can present a great risk at this time of year. All right, now we need to go forward a couple of clicks. Thanks, Catherine. And we'll get to our soil moisture forecast. There we are. So to our soil moisture. So this is where I need you to think back to Catherine's slides at the start of this presentation, where we talked about winter rainfall across the country, and then to Masood's slides on the amount of water in the landscape. And here we have the soil moisture forecast from our model for September, October and November. The model computes the likely flow of water through the landscape, incorporating that knowledge of recent rainfall, the different soil types and topography, and of course the forecast rainfall for the coming months. And as you can see, soils are likely to remain wetter than average along the New South Wales east coast and parts of the interior throughout September, and probably become a bit more widespread across Eastern Australia during October and November. However, soils may dry in parts of Western Australia. So knowing how wet or dry our soils are can provide insight into flood risk, bushfire risk, and as well as, of course, for our farming community that are managing crops and feeding livestock and the like. Next slide, please, Catherine. So speaking of fire risk, our spring bushfire outlook was released last week by AFAC, the Fire and Emergency Services Council for Australia. And the Bureau contributes substantially to this outlook, providing key information on soil dryness, vegetation states, and of course the long-range forecast. So spring is the peak fire season across much of Northern Australia. There's an increased risk of fire in parts of Western Australia's Kimberley region, those red shading there on the map, and also some interior areas during spring. And that follows increased fuel loads. So above average rainfall during the wet season has led to those increased fuel loads. And also the forecast warmer than average temperatures and generally low rainfall at this time of year too. In the southeast mainland, there's also increased fire potential due to an abundance of dry material in grass, scrub and forested vegetation. And that deep layer soil moisture, as Masood showed us earlier, remains extremely low across much of southern Australia, and that does impact the deep-rooted vegetation such as large trees and forested areas and can make them more vulnerable to fire. In the east, recent and forecast rain may mean a later than usual start, say in parts of New South Wales, along the coast there, with hazard reduction burns also likely to be limited or delayed just due to the wet conditions on the ground. But above average rainfall can increase fuel loads and that may impact on fire risk later in the season or heading into summer, where just a few hot, dry, windy days can be enough to dry the landscape and prime it for fire. So fires are a regular occurrence across Australia, with Southern Australia being one of the most fire-prone areas in the world. And serious and destructive fires can occur even in relatively benign seasons. Next slide, please. So let's now look at the broader ocean patterns. And Catherine showed earlier that we've seen warmer than average sea surface temperatures around much of Australia in recent weeks. And in general, we expect that to persist into spring. So particularly off our east coast and to our north, we're likely to see warm ocean temperatures continue. In the Indian Ocean, this pattern of warm ocean temperatures near Indonesia and cooler or near average around the Horn of Africa is representative of a negative phase of the Indian Ocean dipole. Next slide, please. So we're going to move on to our El Nino Southern Oscillation and IOD forecast, but firstly just I thought I'd mention our long-range forecast. So those spring maps that I presented earlier do take into account all the influences from our oceans and atmosphere, including the state of ENSO and the IOD. So if a negative phase of the Indian Ocean dipole is declared active tomorrow, the maps don't suddenly change. They're always assessing the latest state of the global oceans and atmosphere and all the dynamical interactions between them, and then calculating how that will play out in terms of our rainfall and temperature patterns. So they provide the best guidance for rainfall and temperature across Australia. However, looking at broader climate patterns such as ENSO or the IOD can give us some insight into the long-range forecast signal and offer additional confidence in the patterns we're seeing in our rainfall and temperature forecast. Next slide, please. In terms of the Indian Ocean dipole, so here we have forecasts from a range of models. Each coloured line is a different model that we assess. And they're all indicating a persistence of that negative Indian Ocean dipole pattern through until early summer when they return to neutral. And that's in line with our general or our typical IOD life cycle. Next slide, please. And for ENSO, we've shown here our NINO 3.4 index, and that represents the state of ENSO in the tropical Pacific. And most models are indicating a neutral state of ENSO to persist through to early next year, but we do have a couple of models that do just brush the La Nina threshold during spring. Next slide, please. So just to finish up, I'd like to highlight that we have more than just our chance of above median maps available on our website. So I've got a couple here just as an example. So if you click in the left menu on our website, you can see a range of different forecast outputs, such as our outlook scenarios here. So I've got shown here rainfall totals that have a 75% chance of occurring. Next slide, please. And we also have our chance of at least maps. And This is where you can choose a threshold that you might be interested in. Here I've chosen 100 millimetres of rainfall for spring, and see what the chance is of receiving that amount of rainfall. And then of course there's our chance of extreme maps, which I showed earlier today, and several others that you can have a play around with. Next slide, please. You can also get forecast information for your specific location, and many people don't actually know you can do this on our webpage, but you can just click on that little magnifying glass there in the top left corner and type in your location, just as I've done here for Albany, or you can just click on the map in your general area. Next slide, please. So when you do click on your location, it activates a pop-up menu, which gives us here in this example, specific information relating to Albany. So the median rainfall for spring, the chance of rainfall being unusually wet or dry or near average. And here those bar plots show an even chance of rainfall being in any of the 5 bins. So remember those bins that we showed for Uralla earlier, with unusually dry on the left and unusually wet on the right. So you can see they're all showing roughly 20% chance, and hence the map underneath you can see where Albany is there is shaded white, meaning there's little shift towards it being wetter or drier in Albany for this spring. Now if we click once more, we can do the same thing, but for Uralla. So here we see a much stronger chance of rainfall being in the blue unusually wet bin. So Catherine, if we just flick back to the Albany example and we can just do a comparison, there we have the very evenly spread probabilities of falling into any of those 5 bins. And then if we move forward again to Uralla, we can see those odds really favouring that unusually wet condition in deciles 9 and 10 there. So the main takeaway here is to click and explore our long range forecasts. And with that, I think we're up to questions again. So back to you. Thanks, Jordan.
Yes, we are. Thank you, Felicity. That was a real teach Amanda Fish moment. I now know how I can look this stuff up myself, which doesn't mean that you shouldn't come to these webinars, because we do give you exclusive information that you can only get here as well, which Felicity did in her part of it. So I hope that has given you a lot of information on what to expect in the coming months. So all the presenters are back now, and it's time to get to all of your questions. This is a great opportunity for you to address any of the panelists about anything that we've spoken about. So please start sending them in, and we're going to get to as many as possible. Carol has sent us a message, and I think, Felicity, you're probably best to handle this. How frequently do you update the spring long-range forecast?
Make sure I'm off mute. Yeah, so we update. I did mention earlier that the monthly and seasonal forecasts get updated weekly, but we also have, and I didn't refer to these, but you probably can see them on some of the screenshots I show. We also have weekly and fortnightly long-range forecasts as well. And those weekly and fortnightly maps get updated daily. So the short ones are daily updates, and the monthly and seasonal forecast maps get updated on a weekly basis on Thursday afternoons. Yeah, so and then at the start of each month, our outlook period shifts along 1 month. So next week, you'll see when we update on Thursday that our outlook period that currently goes from September out to December will shift to being October out to January.
Okay. And with those long-range forecasts, I actually put those emails together with the help of these guys. So if you'd like to sign up to get one of those, one of the long-range forecast emails, you can do that on our website or info.bom.gov.au. Moving on to the next question, and Felicity, I'm going to come back to you because Linda has asked, how reliable is the forecast?
Yeah, so that's another good question, and always worth asking when you're looking at these maps, and it can vary actually throughout the year. So perhaps we'll start just by talking about the model. So a model is a world-leading state-of-the-art climate model. It is part of the World Meteorological Organization's Global Predicting Centres for Long-Range Forecasts, and was also accepted as one of the top 9 international models to be shown in a multi-model collaboration with countries around the world. So it's really a highly regarded model. Each day it incorporates data like Catherine was talking about earlier, we get observations from around the globe, satellites, ocean buoys, aircraft, land observations, obviously, and all that data is fed into our model, which is run every day. It does all the dynamical equations, hundreds of thousands of equations to create simulations of the climate for the days, weeks, months, and seasons ahead. And those simulations enable the model to account for things like climate change or climate patterns such as ENSO, the Indian Ocean Dipole, the state of the Madden-Julian Oscillation, which is that pulse of tropical activity that it can affect Northern Australia. And it can then produce our rainfall and temperature outlook. So on any day, we have the latest information available based on all those latest observations and the daily running of our model. So that's a bit about the model in terms of reliability or accuracy. So before a model is brought into operations, it undergoes a series of tests that we call a hindcast, and that assesses it for forecast periods in the past. It sees how well the model could forecast earlier seasons, so during the last 30 years or so. And it's a bit like a report card. And you can actually access these accuracy plots or these report cards on our webpage. So you can see how well it's forecast, say, spring rainfall across Australia in the past. So it is one of those options on that left menu where I said there are a few different types of forecast plots and maps that you can click on. One of them is the forecast accuracy maps. And you'll see that in some months or some seasons, there might be areas that haven't performed quite well or performed that well, and others where it's pretty consistent. It has a pretty good hit rate and generally has moderate to high forecast accuracy.
Okay, thank you. Peter has asked, how do you forecast fire weather for upcoming seasons based on your long-range forecast? And you did touch on that a little bit, Felicity, but I think Catherine might be best to answer this question.
We're both heavily involved. I'll give Felicity's voice a rest.
Thank you.
So yeah, we contribute to the AFAC Bushfire Outlook. So this is produced by the fire agencies together with they get detailed bureau discussions and advice in the lead up to the publishing of it. So when we with this preparation, we provide an overview of current conditions such as rainfall, temperature, soil moisture, but we also look at upcoming conditions. And it also includes some insight on fuel variables such as grass curing, for instance. And they combine this met knowledge from us with their operational knowledge. So they know more about what's going on the ground and what they have planned for fire management strategies. So that the aim of the forecast isn't necessarily to forecast fires, but areas where there's an increased risk compared to normal.
Okay, great, thank you. We've received this question from a bunch of people, so I won't attribute it to just one person's one person's name, but a lot of people have been asking about wind forecasts for springs, including some coastal lows in New South Wales. Who wants to jump on that one? Maybe Felicity?
Thanks, Jordan. Yeah, we don't actually do wind forecasts, at least at the moment. Our model doesn't have the I guess the resolution to be able to provide accurate wind forecasting. We do have some experimental products, but they are just that. So we are looking into it, and hopefully one day we can provide a bit more insight into wind. Yeah, in terms of coastal lows and that sort of thing, there is some indication because we have seen quite a few coastal lows this winter, and there is some research that points to the warm Eastern Australian current off the New South Wales coast, and that it can potentially influence some East Coast low activity, particularly during the winter months, and having that sort of very strong temperature gradient from warm ocean temperatures off New South Wales coast and then the cold land. But yeah, we really don't provide forecasts of that at the moment anyway.
Yeah. Okay. Thank you for that. This is I mean, I've been doing these webinars for a while now, and this is always the most common question that we get. We're talking about spring now, and then someone wants to know, what about the next season? So Ian has asked, do we have any idea for the summer outlook yet?
Yeah, it is just that little bit too early at the moment. But as I said, our forecast on our long range forecast webpage does extend out to December, but in terms of the 3 monthly overlapping forecast. So we've got spring, but we also have October, November, December as well. So you can get a little bit of an insight just through our season 2 forecasts on our webpage. But it won't be until early October that we start to get that first look at summer itself, the December, January, February period. So just need to wait a little bit longer until we can get some of that insight into summer.
Yeah, don't forget our emails. We'll keep you up to date as well. info.bom.gov.au. So before we say goodbye today, I think it's a good opportunity to just do a quick wrap of what we spoke about. So anyone who arrived late can know a little bit more about the presentation today. I'm going to give that over to you, Catherine, to just walk us through what happened.
Sure thing, Jordan. I'll just click over to it. So to summarise, we spoke about how winter rainfall was close to average overall. And it was also warmer than average, although the overnight temperatures were cooler in parts of the inland north and east. We've seen many storages in Eastern Australia at or above 100% capacity. Some storages in the south are below 50%. And looking ahead, above average spring rainfall is likely for Eastern Australia. Warmer than average spring days and nights are likely across much of Australia. And in terms of the bushfire outlook, there is an increased bushfire risk in parts of Western Australia and parts of the southeast.
Okay, well, thank you so much for your attendance today. And if you do have any questions that we didn't get to, there's weather questions at bom.gov.au. That's always available to you. Please send them in whenever you think of something. As mentioned earlier, this session has been recorded and we'll have the video sent to you very soon. A really big thanks to our presenters, Masood, Catherine, and Felicity. We can't do this without you guys. We really appreciate all your work behind the scenes. And of course, our team that makes everything possible in the background. They always work so hard in making sure that these are brought to you and they're as fun and as educating and as interesting as possible. Thanks for joining us today. We hope you enjoyed the session and we do hope you'll join us again soon next time. All right, and that's all for us. Goodbye.